Everybody, welcome back to another fun and exciting pre-calculus class. Today we are going to be jumping into chapter number 11. In your book, that is on page number 202. We find out that this lesson is about distance, slope, the straight line, a bunch of different concepts that you, again, should have a pretty good grasp on from Algebra 2. I don't think there's really anything in this lesson that's like, oh, where did that come from? I've never seen that before. So if you will, go ahead, open your book there, and let's start off in lesson number 1. Lesson number 1 is the length and midpoint of a line segment. All right, let's go ahead and look down here. Sometimes I think, let's just not gloss over this real quick. So sometimes I feel like just the way the world wants to make us think is that, like, scientists, people that are smart, don't believe in God. And that is not true at all. If you look through history, some of the greatest minds in history, some of the greatest thinkers, some of the greatest scientists that have ever lived have believed in God and have been believers in Jesus Christ. Johannes Kepler lived back in the late 1500s, early 1600s, said, I believe only and alone in the service of Jesus Christ. In him is all refuge, all solace. So these great thinkers of years gone by, they were Christians, many of them, many of them. And so don't ever fall into that trap of thinking, oh, science doesn't prove Christianity. Science doesn't prove the Bible. Science does prove the Bible. And the problem is that we have people trying to, make up things, trying to bend the science to make it look like God doesn't exist. So, anyways, let's go ahead and keep going there. 11.1, length and midpoint of a line segment. Now, again, these are things that are review. We're gonna spend time on them, but I'm not gonna take a long time. You should already know the distance formula. The distance formula, any 2 points on a Cartesian plane can be measured. The distance can be measured between them using this distance formula. It's based on Pythagorean's theorem. In other words, it's delineated. It's instead of c squared equals a squared plus b squared, we're using Pythagorean's theorem to use points on the graph. So x, y, and the distance is actually technically the hypotenuse. This d for distance over here on the right triangle on the Cartesian plane is actually our r. That is our hypotenuse. So don't get confused by that. So what you would do, because this is a right triangle, right? So you have your length here on your adjacent side or opposite side, depending on which angle you're looking at, one of your legs. And then you have your height here on your other leg. And so you form a right triangle when you do this. And then that hypotenuse right there, that is your distance. So you can do that on the Cartesian plane on whenever you have 2 points. What this is this is a delineation of the Pythagorean theorem using x and y and r, or in this case d for distance. And so this will give you the distance or the space apart that any 2 points are on the Cartesian plane. Turn the page over to 203. And now what we're going to do, and let me just tell you that this is a question that shows up again, like on quizzes and tests, and so you need to understand this. Wrap your mind around this right here. So in the example, they give you 4 points. They give you the A point, the B point, the C point, and the D point. And it says that they are vertices of a parallelogram. Now, I find it interesting that they actually tell you that it is a parallelogram here in the example, in the beginning part, because really the question, what we're doing is we're proving if it is a parallelogram or if it isn't a parallelogram. Now, this one is a parallelogram, but we want to prove that it is a parallelogram. How are we going to do that? Well, in a parallelogram, one of the things about a parallelogram that makes it a parallelogram is that if the opposite sides are equal. Okay, so in other words, AD, all right, this side right here, has to be equal to BC. AD must equal BC. If it does, then it might be a parallelogram. The other thing that has to be true is that AB has to equal CD. If both of those things are true, then we have a parallelogram. So the way that we're going to prove this is we have to plug in our points to the distance formula and see if they equal or not. Okay, so let's jump over here to the computer and let's go ahead and try it. So what I wrote down here was these are the ones that we have to see what they equal. So we need AB. We need this distance right here. So in order to get AB, we're going to use points A and B. It doesn't matter which one you call 1 and which one you call 2. But once you designate, like the A point we'll call point 1, that AX has to go here, and the AY has to go here. You can't put, you can't say, well, this is the A1 point and this is the AY point. You can't do that. It's not going to work. So you have to match them up. In other words, what we're going to do is put in, so square root of parenthesis 1 minus 6. So where did I get those 2 points from? The first X came from the A point, and the X2 came from the B point. Okay, so I have to do the same thing over here. So I just rewrite the formula. Here in the Y, I have to use the A point for the 1. It's very important. I can't use the B point for the 1 here. I have to use the A. I have to stick with, if I designated A as the 1, it has to stay the 1. So this would be 2 minus 10. And that would be squared. Okay. All right. So now, got our square root sign again. And now I just solve these things inside here. So 1 minus 6 is negative 5. And that's going to be squared. Plus 2 minus 10. 2 minus minus 10 is actually going to be 12. And that is going to be squared as well. So it would be minus 12. It doesn't matter. Your signs don't matter because distance is always positive. This is one of those places that I can kind of point out. Some of you have been wondering, why is R always positive? Why is the hypotenuse always positive? This is why. Because the distance is always positive because of the Pythagorean theorem, because of the squareds. These negatives every time are going to come out positive. So your R, your distance, whatever, your hypotenuse is always positive. And this is why, because of the Pythagorean theorem. All right, so we just square this and we would get 25 plus 144. And that would be inside our square root sign. Add those together and we would get the square root of 169. What is the square root of 169? Well, that comes out to 13. So our AB is 13. Okay. Now what we would do is we would do the next point. All right, so I erased it back up to the top. And what we're going to do is I want to do the CD point. So I just want to show you that we're going to verify that the one opposite, so the side opposite AB on our parallelogram is CD. So we want to verify that it is also 13. If it is, then we're good. If it's not, then we've messed up and we need to go back and look at it again. Or what we've done is we've proved that this is indeed not a parallelogram. So we're going to use CD this time. So we're using these 2 points right here to find CD. We're using the C point and the D point. So we'll use 9 as the X1 minus the X2 is going to be 4. And then we're going to square that, plus the Y1 is negative 6. The Y2 is positive 6 minus positive 6. And we're going to square that. Maybe you kind of already look at that and you're like, whoa, what just happened right there? Well, that one's easy, right? So negative 6 minus 6. And then we just go back and we just work through it, right? So we just do these two. So 9 minus 4 is going to give us 5 squared. Plus -6 minus +6. So one way that we could do that is always just change the sign of the second, right, and add. So that's minus minus, so that's going to be -12, and that's going to be squared. And so if you're thinking right, we got the same exact thing we got last time, 25 plus 144, and that's going to give us that 169. Don't forget these are all still in square root signs, okay? And then, so that's going to equal 13. So you come back over here and CD is also 13. So when we get this AB equals CD, we're done. We proved it, okay? Now, I'm not going to take the time and do BC and do AD, but we'll kind of jump back over here to the computer. And if you look at this, you'll see right here that BC is going to give you 5 when you work it, and AD is also going to give you 5. So we proved that AD is 5, we proved that BC is 5, so those are parallel and equal. We proved that DC here and AB are 13, and they are also parallel and equal. So we indeed do have a parallelogram. All right, the next thing that we want to do is we want to find the midpoint of a line segment, find the average of the abscissa and the average of the ordinate. Okay, there's those words again. What is the abscissa? The abscissa is the x, okay? And the ordinate is the y. So don't forget those two. So here's what we want to do. We want to just, we take our points, we take our A points, for instance, and our B points, and we want to find the middle of them. So how do we find the middle of something? We take the two endpoints and we average them, and that gives us the middle point, okay? This dividing by 2 is averaging, okay? So we add our x points, average them. That gives us our x point that's in the middle. We take our y point, we average them. That gives us our y point that's in the middle. And again, you probably know how to do this. You've probably been doing this for a while. This is like Algebra 1 stuff, but we need to make sure that we know it again and we review it for this. So here's our next question. Find the midpoint of diagonal from AC. And so we go back here and they want to know this diagonal from A to C. A to C. So we're going to use these 2 points. We're going to use the A point, 1, 2, and we're going to use the C point, 9, -6. Let's jump back over here to the computer and we're just going to work this. We're just going to go through it. So our A point is 1, 2, and our C point is 9, -6. So let's just go ahead and plug those in. So again, our X1 and our Y1, so those are going to be our A points, and then our X2 and our Y2, those are going to be our C points in this case. So we have 1 plus 9 divided by 2, comma, Y1 is 2 plus -6. And you can put that in parentheses if you want, if that helps you to see that. Okay. Now we would just solve these out. So 9 plus 1, 1 plus 9 is 10 divided by 2, and so that's going to give us 5. So our x point is going to be 5. The middle of this line will be 5. And then we come over here, and 2 plus a -6 is going to give us a -4 over 2, and so this one is going to give us a -2, will be our y point. So our midpoint is 5, -2. Come back over here and we can kind of verify that. Maybe you were following along in your book, but there it is. 5, -2 is our midpoint. All right, so that's really all I have in this lesson. Go ahead and do some of those examples, work through those. If you missed anything in that lesson, scroll it back. This is probably review for you. So take your time here, make sure you get these right. These are basic formulas that you should be able to do. And but you need to practice these because we're going to be using these later on in the chapter and later on in the book. Okay, that's all I got for you. See you later. Have a good one. Bye-bye.